Okay, today we're talking about polygons. And polygons, we're going to look at a lot of different vocab and kind of illustrated examples of that vocab. So bear with me while I type. Our first word is hopefully obviously going to be polygon. And a polygon is a closed plane figure that has 3 or more sides. Right? So a polygon is a closed plane figure that has 3 or more sides. And because a polygon has sides, it also must then have angles. So let's start talking about interior angles. Those are angles that lie inside a polygon. Versus exterior angles, which lie outside the polygon. And let's take a look at what interior versus exterior angles mean. So I'm going to draw, oh, that's no good. It's really no good. I'm going to draw a pentagon. Or a square, if that's what it wanted to correct to. We'll call it a rhombus. That makes it a little nicer. Let's see if it actually will take my pentagon. Yeah, there it goes. Okay, so this rhombus has interior angles here, 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 here. It's 4 sides, 4 interior angles, like that, okay? But when I'm looking at this pentagon, if I extended the sides like this, these angles here would be exterior angles, okay? So that's kind of the difference. So then we can kind of talk about a convex polygon. Which is a polygon in which each interior angle measures less than 180 degrees. Versus a concave polygon, which contains 1 or more interior angles that measure greater than that 180 degrees. So if I'm looking at let's do a quadrilateral. A quadrilateral that looks something like this, like a parallelogram, some have acute angles here and here, but some of them have the obtuse angles. None of them measure more than 180. An obtuse angle is strictly less than 180, right? It's greater than 90, but less than 180. Versus if I draw something that looks like that, these angles here are acute, but this angle is one of those reflex angles. which is greater than 180, if you remember from our angle vocab. Okay? We can also talk about regular polygons, which have congruent sides and congruent angles. So something like an equilateral triangle or a square, those are going to be regular polygons. An irregular polygon does not necessarily have congruent sides or not congruent angles. It doesn't have to have both, just one. Okay? So a lot of times we'll talk about a rectangle being an irregular polygon. It has congruent angles, but it doesn't have congruent sides, which is why it can fall under the irregular polygon thing, versus the square has congruent sides and congruent angles. And we also said an equilateral triangle would be congruent sides, congruent angles. A scalene triangle or an isosceles triangle would be better examples of a irregular polygon. While we're talking about triangles, and we'll go more into triangles later too, because they're very important. Triangles have 3 sides and 3 vertices. Hopefully by this point in time, you kind of know that. A diagonal, this might be a new kind of term for you, is a line segment that connects 2 non-adjacent vertices. So a triangle doesn't have a diagonal, and if we want to prove why, well, all of its vertices are adjacent to the next one, right? So this one's adjacent to this and to this, so I can't really draw a diagonal. But if I were to draw a shape like a pentagon, a diagonal could connect this vertice to this vertice, or this one to this one, because they are non-adjacent. And I can draw many more diagonals if I choose. We had that one already. This is non-adjacent, that's non-adjacent, which is really how we kind of form the star. Fun facts. The last thing we want to talk about with polygons is how to find the measure of an interior angle on a regular polygon. So to find the measure of interior angle of a regular polygon. And what does regular mean again? Good. Regular means that it has congruent sides and congruent angles. Well, we have this formula where I have the measure of the angle is equal to n minus 2 times 180 over n, where n is the number of sides. So let's say I'm finding the measure of a regular regular quadrilateral? Well, we know regular quadrilaterals are squares, and we know that the interior angle of every square is 90 degrees. But let's double check that we can get that answer. So I'm going to plug in. A square has 4 sides. So I plug in 4 for both my ends. 4 minus 2 is 2. If I want, I can go ahead and reduce. Otherwise, I can go ahead and multiply. 180 divided by 2, though, would be 90 degrees. So we were right. A square does have congruent angles of 90 degrees. But go ahead and try this formula for a pentagon that is a regular pentagon.